All right. Some of the IP addresses are called private IP addresses, and these are the addresses you might recognize from your internal network here at Ericsson or from your home networks back home. These are IP addresses, and it's the Class A address 10, the network 10. There's 16 Class B addresses from 172.16 to 172.31. And all the Class C networks, 192, 168 something, 256 different Class C networks. These networks are called private networks. You cannot use them on the internet because they can be used everywhere. So if I would send an IP packet, for instance, if I were allowed, to a Telia router, an ISP, and I say, can you please route this IP packet to 192.168.0.5? Now that network exists in millions of places around the network, around the world. So where do I send it? And the answer is, I don't. Because these can be used internally, but they cannot be used on the internet because they're not unique. They can be used everywhere, locally, within your home network, but I cannot route to it. To be able to route from or to these addresses, we use a router and a functionality called network address translation, or NAT. I'll go through NAT later because we need to go through TCP and UDP ports before we can do NAT. But I'll get back to these private addresses later on. They're private. They cannot be used on the internet. He will throw it away. Yeah. Yes. No. He will probably send an ICMP packet back, but he will throw it away. All ISPs has filters not to allow these. Because if I'm a customer who's with Telia, and I'm sending an IP packet to Telia to one of these IP addresses, and Telia sends that to Tele2 or some other IP ISP, they're going to be the laughing stock of all the ISPs, and they're going to have to buy dinner to all of the people on that ISP, because elsewhere that's going to be spread through the internet that Telia is actually routing the private addresses. So all ISPs have filters to remove these. You cannot use them. It's no use. Yeah, you will probably get network destination ICMP back, probably. But that depends on the filter and the implementation. But you cannot route these on the internet, private addresses. The other ones, in the other ranges, are public IP addresses. Those can only exist in one place, so that they are unique within the internet, so that we can route to it from wherever we are. Now, it's possible that behind those public addresses, you got some of these network hiding behind. For instance, if you got a GPRS or 3G telephone, and you want to run IP traffic on it, you're going to get an IP address. Now, almost certainly, you'll get one of these IP addresses, probably somewhere around the 10 network, because that's what everyone is using, and then you use a NAT translation.
When it comes out passing the NAT, the translation,
yeah,
then all the hosts behind that NAT get the same IP address, but how do they go?
I'll get back to NAT later. Yeah. We need to go through ports before we can do NAT. So. And as I said previously, the first address, the one where all host bits are set to 0, is the network address. So for the Class A network 26, the network address itself is 26000. Is the address where all the host bits are 0. For the B network 128.1, the network address is 128.100. All host bits set to 0. And the same thing for Class C addresses. If I set all host bits to 0, it's the network address, and I can't use it, it's the network itself. And the same thing goes for the broadcast address. If I put all the host bits to ones, that's the broadcast address on the network. So the broadcast address, if I want to send something to every single PC, every single host on the Class C network 192.110, I would send that to the IP address 192.11255. That's the broadcast address on the 192.110 network. Every single IP host is going to receive it and look at it because it's the broadcast address. That's the network's own broadcast address. Remember we talked about the generic or general broadcast 255.255.255.255 as well. All network has its own broadcast address as well. So routing between networks, obviously, since the routers keep track of the network, I can't have the same network on different places. If the router in the middle, if network number 1 and network number 3 would be the same network, how would the routers know whether to send it to 1 or to 3? I need to have different networks. Every single network has to be unique so I can route to that network. And now we're getting into problems because we don't have enough networks. 2 million networks might sound like a lot of networks. How many networks does Ericsson have? Just here in Kista, probably hundreds of networks. Just here, this place. Smaller companies, even 200 employees, if they have like 10 offices around Sweden, they might need 20 networks to connect them. Small company. Even smaller companies might use 2, 3, 4, 5 networks. Now, on a world basis, 2 million networks, sorry, it won't do. Not even close. So that's what we'll do in the next chapter. We'll talk about subnetting. But for now, we need to make sure that we got unique IP addresses and unique networks so that the routers can route between the networks. Host IDs, so the host part of the network address has to be unique. We talked about that. Network ID cannot be 127 because it's used for the loopback address or local host address. The network ID and host ID cannot be all ones and cannot be all zeros. If the host is all zeros, that is the network. If the host bit is all ones, it's the broadcast. Questions so far on IP addressing? All right. Chapter 4, subnetting. You know that there's a mask on an IP address, right? Have I talked anything about subnet masks? Anyone know the reason why we haven't talked about them? Because they didn't exist. Subnet masking and subnet masks are a thing that we came up with to solve a problem, and the problem is we didn't have enough networks. So we need to use the network more efficient than just having A, B, and C addresses because it's not good enough. So subnet masking and subnet masks were not supposed to be. It's an extra thing to solve a problem, as has been done in IPv4 with lots of different things. It is, yeah, there's an RFC, but it wasn't in there in the beginning. It is an RFC, sure. So we'll look at what the mask is and how we use it and why it's there. And then we'll go through some of it. And then we'll talk about something called classless interdomain routing, just quickly. I always, when I do IP addressing, I do this. Let's imagine, I'll do ordinary routers this time. Let's imagine we have a small company based here in Sweden, and my little company with 200 employees. We have offices in Sundsvall, where I'm from, in Stockholm, Malmö, and Gothenburg. Now this small company, we have only 200 employees or something like that, or 100 employees. I got office in 4 places, and I got WAN links between them. This then is 1, 2, 3, 4, 5, 6, 7 networks. 7 different networks. We need to have a different network here and here. Cannot have the same network here and here. If I'm on the PC here and I want to send something to a server down here, I'll say send it to this server. It's going to be routed to I'll send it to my router. He will send it to this router. He will look at the IP address and say, well, do I send it down there or do I send it over there? If it would be the same network here and here, how would I know? Right? I need different networks everywhere. So I know where to send it if I'm a router. Okay with that? Now this small company, 100 employees, would need 7 networks, 7 IP networks. So I'll get in touch with my ISP and I say, well, small company, I need 7 network. And since the smallest network you have is Class C networks, could I please have 7 Class C networks? And he was like, no. You cannot have 7 networks because we don't have that many networks. So what we need to do is we need to be able to use our networks more efficient. So he will probably say, you will get this one network. Use it. What class is that? C, Class C network. This is a Class C network. Use it and use subnet addressing. Now, usually, a Class C network, if we were doing just classes, would be network, 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 host, right? That's the basis of class, right? If it's Class C, that's the way it's supposed to be. Now, what we're going to do when we do subnet addressing is if you imagine that all of these addresses is this area. These are all addresses in that network. I need a bit somewhere. Can you see this? These are the 8 bits in the 4th byte. These are the bits that are, if you like, the host bits. Right? I got 8 bits if it's the Class C address, right? Now what I'm going to do is I'm going to start to borrow bits from the host part. If I borrow 1 bit from the host part, and instead of having this bit here, the first bit in the 4th byte, instead of having this bit being a part of the host part, I'll use it to differentiate between if it's a 0 or a 1 here. And if it's a 0, I will use that bit to let me know that this is on this side. And if it's a 1, it's on this side. So instead of using this bit as a host bit, I'm using that bit to differentiate between this half of the addresses, and that one. You okay? On every single part here now, I got 1 bit, this one, that tells me whether I'm here or here, and then I've got 7 bits left. Those 7 bits is going to tell me which IP address I am in this part, or if it's a 1, what IP address I am in this part. Now I've borrowed 1 bit, and I'm using that bit to create 2 subnets, part of the original net, 2 subnets. Okay? Is it okay for my network to have 2 subnets? No, I need 7. So I'll borrow another bit. If I borrow another bit, that bit could be 0, in which case it could be 00, 01, 10, or 11, right? Those 2 bits. Meaning that I'm now splitting this into 4 parts. If it's 00, it's here. If it's 01, it's here. If it's 10, I'm in that part. And if it's 11, I'm here. I've now borrowed 2 bits that used to be host bits. I'm using those 2 bits to create 4 subnets. And every single subnet still have 6 host bits to let me decide which host on this subnet am I, or on that one, or that one, or that one. Is it good enough? Nope. So I'll borrow another one. And if I borrow another one, that bit can also be 1 or 0 in all of these positions. Now this will be messy now. I'll split it again in half. If it's 000, it's here. If it's 001, it's here. If it's 010 or 011, 100, 101, 110 or 111. I've now used 3 previously host bits to create 1, 2, 3, 4, 5, 6, 7, 8 subnets. All of those subnets still have 5 host bits left, so that I can have hosts on these subnets. Is it good enough? Yes. For now. For now. You okay with this? Now the problem for us now is that I might, in a given example or a given network, borrow 1 bit. Or I borrow 2. Or I could borrow 3 or even 4 or 5 or 6 host bits, and I'll use those bits to create subnets. Now if I look at an IP address, I told you previously, an IP address is 2 parts. A network part and a host part, right? Previously, it was really simple to see what part is network and what part is host, because it was all classes. Now, I'm borrowing bits, and I'm borrowing different numbers of bits. Sometimes I'm borrowing 2, sometimes I'm borrowing 4 or 6 or 5. I need to be able to let the people or routers or PCs looking at my IP address know how many bits have I borrowed. Because if you remember, I said that the IP address is 32 bits, right? One part is network and the other part is hosts. When I look in IP address, I must know which bits are the network bits. And the only way to know which part is network and which part is host when I'm starting to borrow bits is to let people know. And that's what the subnet mask is doing. The subnet mask is telling me what number of bits or what bits are network bits. That's what the subnet mask says. So in the first example, when I only borrow that bit, I'll have a subnet bit that will tell me that I've borrowed this one. In this case, where I borrowed 3 bits, I have a different subnet mask that will tell everyone looking at it that I've borrowed 3 bits. If I borrow 4, I'll do a new mask that will tell people, routers, PCs, that I've borrowed 4. I'll tell them that. I need a subnet mask because removing this place where the divider is. Split between the network part and then the host part. And the subnet mask is really simple. It's once. So if this is the total IP address, this is the network part and this is the host part, I will put in a subnet mask once on all bits that are a network bits. If it is a network bit, either because it's a class C address, so all of the first 24 bits are networks, and then I've borrowed 3 extra, I'll add 3 extra to the subnet mask, 3 extra bits. All bits that are hosts are zeros in the subnet mask. Okay? The subnet mask is once if that bit in the IP address is a network bit. If the subnet mask bit is a 0, that bit is a host bit. Now, today, the subnet mask has to be consecutive. It has to be once all the way till I put the first 0. Once I put the first 0, the rest of the bits are also host bits, so the rest of the subnet mask is also zeros. It is all ones till the first 0, and the rest is also zeros. I cannot have a subnet mask being 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. It's all ones and then all zeros. You okay? Yes, because every subnet you create is going to use one address, the first one, to let everyone know this is the subnet, the network itself, the first one, and also one for the broadcast address. So in our case, when we did 8 subnets, we've lost 16 addresses, or 14 because we had 2 in the beginning, right? Now since we created 8 subnets, we're losing 16 addresses. So when you do create subnets, you lose a number of IP addresses, but you gain subnets, which we need. So it's a trade-off we have to do. Remember this? We went through this before the break, and we didn't talk about masks, right? At all. This is the way it works. Now imagine, since you now know what a mask is, if I would want to do a mask that would tell me this, how would that mask look? Well, it will be once on all bits that are a network bit, right? That's a subnet mask. Every bit that is a network bit is a 1, right? So the mask for a class A network would be 1, 1, 1, 1, 1, 1, 1, 1, 8 ones, right? Because these 8 bits are network bits, right? The other 24 bits would be zeros. I won't do 24 zeros. Right? This is what's called the natural class A mask. It's the mask that class A network had before we had masks. If you understand what I mean. It's the natural class A mask. If you write this in dotted decimal notation, if all bits in a byte is set, it will be 255, right? So it will be 255000, right? Recognize that? It's the subnet. It's a natural subnet mask for class A networks. Same thing with class B. Network, 8 bits. Network, 8 bits, 00. This is the subnet mask that tells me what I already knew about Class B networks. It's sometimes referred to as the classful Class B mask. Same thing with Class C. It's 255, 255, 2550. Matter mask for Class C network. The mask that Class C networks had before we even had masks. All right? This is very long. It's a long way to write. So today, because the network mask has to be consecutive, with most of us anyway, have stopped doing this. We have to in some instances, for instance in a Windows PC. But if I would write this, I would have the number of bits. And these are 8 bits in a row, right? So instead of doing this, we do that. It's called the prefix length. What's prefix? What's the prefix? What's pre? The first one, right? First part. Now an IP address is network and host, right? The first part is the network part. This is the prefix length. It's the length of the network. It's 8-bit. It's an 8-bit network. How many ones in a row is this? 16. So instead of doing that, I can do this. Instead of doing this, I can do this. It's a 24-bit network. The first 24 bits are network bits. The other 8 bits are hosts. We can do this because we cannot have, or the subnet mask has to be consecutive. All right? If you go back, remember that I borrowed 3 bits in my example with our little company, that we borrowed 3 bits from the host bits, right? So what would be the mask on those subnets? It will be a 27-bit mask. So 24 to start out with. Because it's a Class C network, right? So the natural mask would be a 24-bit mask, 255, 255, 2550. And then I borrowed 3 bits and used those bits as subnet bits, which would mean that the subnet mask would be 1110000. 3 extra bits. So this network here would have a 27-bit mask. Now, if I want to write that in dotted decimal notation, it will be 255, 255, 255, those 24 bits. And then I add up these 3. So 128, 192, 224. So the mask for a 7-bit network would be 255, 255, 255, 224. It's the same thing as 27-bit mask. All right? I won't go more into subnetting because I'm told you're not supposed to do the calculations yourself, but you need to know what the mask is. Any questions so far?
This is only used to plan up the network.
It's only used to...
You use this in order to plan up the network.
Yeah.
Basically.
Yeah. You use it to use the networks more efficient. Remember I talked about Class A networks, right? And we said that in a Class A network you can have 16.9 million hosts. Is that a useful network? Nope. But I can use that Class A network and I can subnet it into smaller parts. And I can use those smaller parts in lots and lots and lots of networks if I got a Class A network by subnetting it. Same thing they've done here. They haven't put the mask in there yet, but I would imagine this is a 24-bit subnet mask. 190 is what class? B. Class B, all the way up to 191, right? 192 is where C starts. So this is a Class B network. What they've done is they've taken a Class B network, 190.100, with 16-bit mask, 255.255.00, and they've subnetted it up to a 24-bit mask. So instead of having the 2 first bytes being the network part, I've added 8 extra bits, making it a 24-bit mask. So now we have subnets 191.10.0, 191.100.0, and 191.20.0. 3 subnets from the same Class B network. All right? What your PC is going to do when he's supposed to send an IP packet, he will check his IP address, and he will use his mask, and he will look at the destination IP address and his own mask. Because I don't know the subnet mask on the destination, so I will use my own. If we're on the same network, we should also have the same mask, right? Because otherwise we're misconfigured. So if I take my IP address with my mask, I take the destination IP address with my mask, and I look at the network part of that. If it's the same, we're on the same network. If it's not the same, the destination is somewhere else. And he doesn't have to have my subnet mask if he's somewhere else. But I can find out whether he's on my network or not. Because if we're on the same network, then we have the same mask. So the host will check my IP address and the destination IP address, and I will use my mask to check whether the network part is the same. If it is, I can send it directly to that host because we're on the same network, same broadcast domain. If it's not the same, where do I send it? To my router or to my default gateway? So which one is it? Well, they are the same. A default gateway is just an awfully horrible, bad name for the router interface. Default gateway is a router interface on the router connected to your network. That's what it is. Nothing other. That's why a PC needs a default gateway. Because when the PC finds out that his address, his network part, and the destination network part, the destination's network, isn't on the same network, where do I send it? Well, I'll send it to the default gateway. I'll send it to the router, and the router will route it. If I don't give or have a default gateway, I can't route to anyone outside my network because I don't know where the router is. Right? That's why we need a default gateway. So if it's the same, I can send it directly because we're on the same network. If not, I send it to the router. Physical output. From a physical point of view, remember we talked about VLANs, virtual LANs, and LANs. Now, on layer 2, we're talking about LANs and VLANs. On layer 3, they correspond to IP subnets. So if I have a LAN, that LAN is going to have a IP subnet. If I have 10 VLANs, each one of them is going to have its own subnet. And if I want to go from one VLAN to another, I'm going to go via the router. And the router will route me from one IP network to another IP network. Right? And the mask is used to let me know which IP network I'm on and which IP network the destination is on. So in this case, class B address again, 190.1.0.0 network. They have the classful subnet mask, 255.255, and then they've used another 8 bits from the host part, and they've created subnets. So they've prolonged or added 8 bits to the subnet mask. So now we're using 8 previously host bits for subnets, giving us a total of 256 possible subnets. And then each one of those have 8 bits left for hosts. These are the default subnet mask. Since this is a class B network, it's a 16-bit subnet mask, 255.255.0.0. It's a classful or natural mask for class B networks. This is another example. This is more or less the same, but instead of having to borrow 3 bits in the 4th byte, as I did, we're now borrowing 3 bits in the 3rd byte. And since we're borrowing in 3 bits, the subnet mask will be 255.255.224.0. How many subnets do I get? 3 bits. 8 subnets. If I borrow 2 bits, 2 subnet bits, how many subnets do I get? Remember we did that? 4. So why does it say 2? If I borrow 3 subnet bits or 3 host bits, how many networks do I get? So why does it say 6? There is something called IP subnet 0, or the subnet 0 networks. Old time, way back, when all hosts didn't understand subnet masks, we were not allowed to use all subnets. Because imagine I got the class C network 194.10.10.0 with a 24-bit mask. Now, if I subnet that into 27-bit masks, 27-bit subnet, the first subnet would be this one. Now, if I don't understand subnet masks, what's the difference between this network and that network? Is there one? Back when everyone didn't understand subnet masks, we weren't allowed to use this subnet because we can't differentiate between that one and this one. Now, every single router today and all hosts, not all, but almost everyone understands subnet masks. So today, we use all subnets. If you ever configure a router, there might be a parameter or a switch or something that you need to turn on or turn off for them to allow you to use all subnets. That's one of them. The other is the one where all the this is the subnet where all the borrowed bits are zeros. Remember we borrowed bits, right? If I borrow 3 bits and they're all 0, the network, the subnetwork, is going to be the same, have the same number, 194.10.10.0, with a 27-bit mask instead of a 24-bit mask, because these bits that I've borrowed are all zeros. The other network that is subtracted in that one is the one where all the borrowed bits are 1. So the first and the last subnets. Previously, you weren't allowed to use them. Today, we use them everywhere. except if you have a network that is really, really old and you haven't reconfigured it for a long time. But otherwise than that, we always use all subnets today. You might have to tell your router that you're allowed to do it, but today they should be able to use it. Because the subnet mask has to be consecutive, there cannot be any zeros in between. These are the only decimal values you could have. These are the only possible ways to end a subnet mask. If I just borrow 1 bit from a byte, it will be 128. If I borrow 2, I need to borrow 1 and 2. I cannot borrow any other bits, and in which case it will be 192. If I borrow 3, it will be the 3 first, in which case it will be 224. If I borrow 4, it will be 240. It cannot be 237 or 250 because it has to be consecutive. And because it's consecutive, these are the only possible values. All right? The network address, we talked about that. The address for the network itself, all host bits are 0. The network broadcast address, where all host bits are 1s. It's the broadcast address on that network. And the subnet address is the same thing. So this subnet that I've created, how do I know it's a subnet? It's the network itself. Well, I do know that by putting all the host bits to 0. If the host bits are 0, it's a network. If the host bits are not 0, it's either a host address, or if all of them are 1s, it's the broadcast. Do you understand what I'm saying? So same root again. Host field can't be all zeros or all ones because it's the network and the subnet or the broadcast address. Traditionally in this case meaning far, far back in the history of humankind. But a long time ago, we couldn't use subnets that has all zeros or all ones in the borrowed bits. And you can see that RFC, the request for comments, is what's used for those standards. It's the IETF, the Internet Engineering Task Force, is responsible for writing the RFCs. Now, the RFCs 1878 and 1812 allow the use of all zeros or all ones. Now, you might not know this, but 1800 RFCs are old ones. This is way back. And some vendor routers do not support. Every router you buy today, they do support all zeros and all ones in the subnet part. You might have to configure it to support it, but it does support it if you buy it today. Example of Class C subnetting, we've done that. I'll do this because this is kind of, I've forgotten about this. If you remember this one, because I run out of space, then I'll do it up here. And now we decided to borrow 3 bits, right? So I'll put this line up there. These are now network bits because I've decided to use those to create subnets. And these are the host bits, right? And this would be a 27-bit mask now, right? Because that's 3 extra in the 4th byte. Okay, so far. Now, the 8 networks that we created, what will the network be called? The subnets. What's the name of the subnet? And what are the possible hosts to use on those subnets? Well, if it's a network address, how do I know that an IP address is a network address? How do I know that? Been through that lots of time on the slides. How do I know it's a network address? I put zeros in the host bits, right? If all host bits are zeros, it's the network address, right? Right. So since I'm interested in talking about the networks now, I'll put these bits to 0, making sure it's a network, right? Now I'm borrowing these parts to do subnets, right? And we said that it could be 0, 0, 0, or it could be 0, 0, 1, or it could be 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, right? Eight. Good. Now, what would be the subnet? What would be the first subnet? What would be the name or the address for the first subnet? Well, it's this one, right? So it will be 194.10.10 because that's the class C address we had. And in the fourth byte, it will be all zeros, right? So the first subnet would be 194.10.10.0, and it would have a 27-bit mask. This one, right? What's the next subnet? Well, since it's a subnet, the host bits are still going to be 0. Now the subnet part is 0, 0, 1. And the total in the fourth byte is what? $194.10.10.32. So the next network would be 194.10.10.32 with a 27-bit mask. It's a network. You cannot put this IP address on a PC. It's a network address. Same as 194.10.10.0 with a 24-bit mask. It's the network address. What will be the next network? Next one. Anyone see any logic in that? You know that IQ test? What's the next number in this series? 32, 64, and 96. There's a difference between them with there's a 32 difference, right? Now, when I do this bit to the left of the line, it's called a delta bit. As soon as you put and you know where the split is, you also know what the network is because it's going to be 32 between them. So the 4 networks, or the 8 networks are 0, 32, 64, 96, 128, 160, 192, 224. 1, 2, 3, 4, 5, 6, 7, 8 networks. These are the networks. If you have a 27-bit mask, it will always be these numbers in the fourth byte. Now, depending on the classful network you have, you might have different things in front. But if you have a 27-bit mask, these are the networks. Because you will also always have a 32-bit delta bit. And will always be these.
But in the case now, then you're only using 4 subnets for your actual employees.
Yeah, but I also have networks for the WAN links. So, for instance, I could put the 32 network in Sundsvall. I can put the 64 network in Stockholm, the 96 network in Malmö, and the 128 network in Gothenburg. If I do that, what IP addresses can I put on PCs in Sundsvall? Can I put 32? No, because that's the network. But I can put 33 up to 62, because 63 is broadcast. Malmö, 96, can't use 96, but 97 to 126, because 127 is broadcast on the 96 network, and so on. Okay? We need a break soon. Subnet address, or the address for the... Yeah.
255 will then be just broadcast in the 8th network, but if I want to broadcast in all 10.
Which is the other reason why we weren't supposed to use the final one. Because what will be the broadcast address on this network? It will be 194.10.10.255, right? That's the broadcast address on this one. What's the broadcast address on the 24-bit network? The whole Class C network? The same. 194.10.10.255. How do I know if it's broadcast on the Class C network or if it's broadcast on this subnet? I don't, unless I know the mask. Which is why we weren't allowed to use this one either. So remember that IP subnet 0, where we can't use this one and we can't use that one. Traditionally. Long time ago. You okay?
The broadcast on the whole internet is not that case.
What does a router do with a broadcast? What does a router do with a broadcast? Will I send it on? No. I throw it away because it's a broadcast. I will check it because it could be for the router itself. I won't send it on. Now, I might send these on, but that depends on the router implementation. So I won't go into that. Wow. We're running out of time. We're definitely running out of time. This is the prefix notation. All the prefix from 0 to 32. Now, remember that in my network, my example, we had 7 networks, right? So I put 32 here, 64, 96, 128, 160, 192, 224, right? Okay? All with 27-bit masks, right? Now, what's the reason why we started out doing subnet masking? Lack of networks, right? Lack of IP addresses, right? So if I have a lack of IP addresses, how many IP addresses do I need on this WAN link? 4? Okay, how many host addresses do I need? 2. 1 on each side, right? If I'm now running out of IP addresses, why would I put a subnet on this point-to-point link, which allows me to have 30 hosts when I'm only ever going to use 2? That is throwing away 28 IP addresses, which I can't use anywhere else because we need unique networks, right? And the answer is, we don't. What we've done so far is called fixed length subnet masking. What most people do is variable length subnet mask, meaning that I don't have to have the same subnet mask on all networks. I could have some networks with 27-bit masks on, and I can have other networks, for instance this point-to-point, with a 30-bit mask on. Because if I have a 30-bit mask, it will allow me 2 hosts. I won't go into variable length subnet masking more than that. But that's what we do. So, different length of subnet masking. Okay, final thing before we're done with subnets, and we're running really late now. Classless into-domain routing. What was the use? Why did we have classes? IP address classes. What's the use for class A, class B, and class C networks? Why did they divide the address space into class A, class B, and class C? What's the reason? Why did they do it? To have different size of network. So that I knew that if it were a class A network, the first byte was network and the rest was host, right? Do I need that if I have a subnet mask? It's the subnet mask that tells me what the network is, right? I don't need classes. And to be honest with you, we started with classful into-domain routing, or classless into-domain routing some 10 years ago. And we don't really need classes anymore. You still need to know about them because people talk about them a lot still, but we don't really care about them. Because today, I got an IP address and I got a mask. And that's it. I don't care about anything else. Questions? No. We'll go through that. Any other question? Good. You now know some things about IP addresses anyway. Next chapter. Are you all free tonight? Yeah. Unfortunately, I got daycare. We'll go through something called DHCP. Now, there are different ways to get IP addresses. You could, if you want to, go in on every single PC and device and manually configure it, static configuration. What we used to do. But if you do that, you might misconfigure somewhere, and you might have trouble finding that misconfiguration. It's also kind of, there's a lot of administrative overhead. Now imagine Ericsson decides suddenly, we want to change IP address plan. Now how many PCs and equipment do you have only here in Kista? Not 2. A lot of them, right? So if I want to go around and change it manually on every single PC and all devices, it will take me probably 2 years or something. And also if you do it wrong, and if I'm doing all of the PCs, I'm going to make some mistakes. And if I do it wrong, we won't be able to communicate. So what we're doing is we're using something called DHCP, Dynamic Host Configuration Protocol. And that's what, in Windows, when you say, you go into IP configuration, you say, obtain IP address automatically. That's DHCP. Before DHCP, there was something called reverse ARP, and there was something called bootp. I won't go into these now. So DHCP, then, Dynamic Host Configuration Protocol, what happens is, when your PC turns on, he doesn't have an IP address. So he will send out a request, and he will get an IP address from a DHCP server. The DHCP server has something called a scope, where he has a number of IP addresses that he can share, that he can borrow to clients. And he will take an IP address and he will borrow that to the client for a certain number of hours, depending on who created or who configured the DHCP. I will also get other information from the DHCP server: subnet mask, default gateway, DNS server, and other server information I might need. Lots of options in DHCP, but the IP address, subnet mask, default gateway, and DNS is the most important ones. So your DHCP client, your PC, is going to start out by sending out a DHCP request. This is broadcasted out on the network. Every single server, DHCP server, that sees this is going to respond with a DHCP offer. Now, because I'm broadcasting it, and because there might be more than one server on the network, I might get multiple answers. The client is usually going to use the first one. Could be the other one, but usually I'll decide to use the first one, and I send a DHCP request. This is also broadcasted on the network, so that I tell all servers what IP address I've decided to use. It lets the one server that I've chosen know that I've chosen that server. It lets the other servers to remove the offer that he sent because I'm not using it. So everyone gets to know what IP address I've decided to want to have. And then the server that I chose is going to send a DHCP acknowledgement. And it's once I get the DHCP acknowledgement from the server, that's when I can start using that IP address. I can then use the IP address until my lease time is up. Remember that DHCP is a broadcast, right? So if I'm a client on the left side of the slide, and I'm broadcasting a DHCP request saying I want to have an IP address, what will the router do with a broadcast? Throw it away. So if my server isn't on the same network, so I need to route to get to the server, I need to configure the router. I need to tell the router that if it is a DHCP broadcast, you need to send this, and I will point to the server. In Cisco language, it's called IP helper. And usually we call it a BootP or DHCP relay agent. You need to set up the router to send on BootP DHCP requests. Otherwise, it will throw it away because it's a broadcast. Questions on DHCP? Do we need a break? Let's have a short break then.